Hello everyone, Aaron here. Welcome back to Leetcode, and today we are continuing on from the video we did last time, which was designing a hash set. Today we are designing a hash map. Let me just very quickly check something. Yeah, okay. So like last time, we know the domains of the keys and the values, but that is less important. So we can basically reborrow our strategy from last time, which was we initialize an array that is large enough to hold everything we want, and then just use the key as the hash. This isn't how hash maps usually work. Normally they have to be dynamically resizable because you don't know the range of the keys. So for example, if all you're told is the keys will be integers, you can't allocate an array that is available for every integer. That's just massively wasteful. So you'd have to do some dynamic resizing. We can avoid that, so we will. Let me have a quick read of the instructions. So we're designing a hash map without using any built-in hash table libraries. Implement the myHashMap class. MyHashMap initialize the object with an empty map. Put the key and value into the hash map. If the key already exists, update the value, so just replace. Get gets the value, or -1, because all the values are positive. And remove removes the key and its corresponding value if the map contains the mapping for key. Alright. In that case, so last time we did a whole lot of tricks at the end. Once we'd set up our hash set to things like bit packing and reducing the size and doing speed outs. We can't do those kind of tricks here because we need to store the values. But basically what we want is to do a pointer to an array. Well, to do an array effectively. Int star values. This is an array of integers. So we need to create this array just as we would expect. We want to do int star values equals malloc size of int times size. Like last time, we're going to make size equal to, what is it? 10 to the 6, 1, 2, 3, 4, 5, 6, plus 1. Then we can do my hash map star obj equals malloc size of my hash map. So this is all entirely the same setup as we did last time. The one difference is rather than having a bool array or the more funky unsigned ints, here we're just making them int because that's what we want to store. We've been told we're storing integers, so let's have a place to save integers. There's one last thing I think I want to do here. So it says we should return -1 if the value doesn't exist. I think it would be a very good idea if we pre-populate the array with -1s, just so that when we go to read something, if it's filled with garbage, well, obviously we don't want to accidentally give the garbage back, but we can't fill it with 0 because if the value we've stored is 0, we then can't tell the difference. But we know we'll never be storing a -1, and we know that we have to return a -1 if the value isn't present. Now, one thing I could do here is memset. So if I were to go values, put a -1 in for size, this wouldn't work, but if I did times size of int, this would work, but this would only work because of a unique property of -1. It also works for 0. -1 and 0 are special in memset and that they will work, but what memset does is it actually puts the byte that corresponds to this value in every byte of the array. Now 0 works because it looks like this as a byte, all zeros, and -1 works because it looks like this as a byte. We have all zeros and all ones. If we had 1, for example, this would get copied for every byte, and an int is usually 4 bytes long, so we'd end up with this byte copied 4 times, which is not 1. That's 1 plus 2 to the 8 plus 2 to the 16 plus 2 to the 24. Well above 1. So we could do a memset. We're not going to. It's just confusing and error prone, although in this case it would work. Right. We've got the values, we've returned the object, so now if I want to put something in, I want to go obj values key equals value. Now I want to get obj values key and remove it. Obj values key is -1 because that's our empty, and then I want to go free obj values free obj. Not too bad. Forgot a semicolon. And another one up there, but I need to make sure I return. I think this will do it, to be honest. So if we put 1, 1 into the hash map, index 1 gets assigned a 1, index 2 gets assigned a 2, get 1, go to position 1, it'll return 1. Go to position 3, we'll return -1 because that's what's there. Let's do a quick run just to make sure we haven't got any syntax bugs, but I think we'll be good, and submit it. Excellent. We weren't terribly fast, we weren't terribly memory efficient, but it worked fine. We were yeah. Just trying to think if there's ways we could make this better, but short of the dynamic resizing, it's kind of hard to make this better. Speed-wise, the memset would probably help. Hard to see how we could do much better speed-wise if we didn't memset. Let's give that a quick go, shall we? I know this is very much a case of do as I say, not as I do. So memset values with a -1. In fact, to make that super clear, I'm going to call it an OXFF because that's 11111111 in hex. And then I'm going to do that for size of int times size. Does that work? Still reckons it works. Let's see if we're any quicker, because that's about the only bit that I can imagine would be slow. Oh, massively faster. We cut a third off the time, which bumped us way up. We're now middle of the pack completely. Memory usage is still exactly the same. That's not a surprise. It's really hard to see how we could be more runtime efficient, to be honest. The mallocs are about as good as they're going to get. We could tweak this a wee bit. And then this removes one layer of indirection, which could potentially help. Yeah, the reason I had to get rid of the star up there is because everywhere we're handing around a pointer to a hash map. But here it's already a pointer. I would sort of end up with a doubled pointer. So it looks a bit weird, but it does kind of balance out. What's that done? That's cut another... Oh, so that double indirection was costing us, which makes sense because we had to dereference the container and then dereference the contents of the container. So that was 2 memory accesses where we really only needed 1, and that has saved us almost another 50%. Our memory usage keeps climbing, so we're doing worse and worse and worse, but our runtime keeps decreasing, so we're doing better and better and better on that side. As always with these things, it's a trade-off. You have to decide whether you're trying to go fast or whether you're trying to be memory efficient. We are not being memory efficient here. I think that'll do us for today. A nice short one. Thank you very much for watching, and I will see you all tomorrow. Bye. Do as I say, not as I do.